Okay, so now we're finding an area underneath a curve that's defined by a table. And one thing I'm noticing about this table, do you see how the y values are decreasing? So I suspect this will mean that let's see, how much is it decreasing by? It's dropping by about 150, then it's dropping by about 100, then it's dropping by um, what about 75, and then it's dropping about 50. So I think you see how the rate of change in the velocity is decreasing. So I'm going to suspect this is a decreasing. I'm going to suspect that this graph, if I plotted those points, it would be concave down. Okay. Or actually, it would have to be concave up because it's the rate of change is decreasing. So it's like this. So that would tell me. So so keep that in mind, and once we get this done, we'll talk about it. So the other thing I'm noticing now, they're telling me to do this with four rectangles, and of course they only gave me four sections here, so that's great. And the other thing I'm noticing is that they're all the same distance apart. They're all 1/2 apart. So that means each of these rectangles are 1/2 wide. Pay attention, that's not always the case. In fact, the one on the quiz probably isn't going to be like that, right? You're going to have to pay attention to how wide they are in the x's. So, but the calculations are really easy. If I'm going to do an LRAM, that means I'm going to use the left endpoints, right? So I know that the rectangle is 1/2 wide, and I'm going to go with the left. So I'm going to go with 490, 495, right? So that's this one. See, I don't know. I'm making this up how wide how high they are. But so there's the left. There's that first one. Here's the next left. Here's the next left, and then of course I kind of dropped out. I would have another left here. Let's pretend these are coming down lower. Okay. So the first one is going to be 1/2 wide by 495 high. The next one will be 1/2 wide by the 349. You see how that's the next value. So that's see this side is 495 high, and this next side is 349 high. This next one is 246 high because that's where how far it is from the x-axis up to the curve. So let's see. So we're going to do 1/2 times 349. So there's two rectangles. 1/2 times 246, which is the third rectangle, and then 1/2 times 173. So notice I'm not using the 122 number when I'm doing the LRAM. Now, if I'm going to do an RRAM, a right RAM, we're doing the right rectangle, so we're going to go from the right. So if this is the graph, right? RRAM, let me not do that. Let's undo that. I want to erase this. And so RRAM would be saying, okay, here's the endpoint. So RRAM would be looking like this. I'm going to go from here, from the right endpoint down, from the right endpoint. I know that doesn't look the same width. Right endpoint, right endpoint. So in this case, I'm not using, see, I'm not using the 349 number. So it's going to be 1/2 times I'm sorry, I'm not using the 495 number. I am using the 349 number. So 349 is my first height. See how it's kicked it up one? So 1/2 times the next one, which is 246, and then 1/2 times the next one, which is 173, and then 1/2 times the next one, which is the 122. So here I am using the 122. I'm not using the 495. I'm hoping this, and then you just multiply those and add them all up. I'm not going to bother doing that. Um, okay, but that's how you do the RRAM, MRAM. This is not the first time you've seen this, so that's why I'm not too worried about finishing it. I just wanted to refresh your memory and how to do the LRAM, RRAM. And I'm not going to ask you an MRAM here. If I was going to do an MRAM, I'd have to cut down on the number of rectangles because they didn't give me enough information to do more than that. I'd probably do two. Okay, so that's so LRAM, RAM, and then what's the units? Well, we're multiplying seconds times centimeters per second. So if you think about unit analysis, the seconds cancel out. So that's going to be centimeters is what the units are. And it's the distance traveled. Okay, so hopefully that helps you do this question.